Can a 7 days full 100% CPU load burn-in stress test damage a modern notebook? When I buy new computers, I usually do a burn-in with 100% CPU load for, say, 7 days, in a well-ventilated place. This is to find out if the computer has problems before I invest time into setting it up for me. Let it steam out some of the plastic/chemical gases before I use it in my home. But, now I'm wondering, am I creating hardware problems by doing this? Are modern notebooks built to withstand this? I guess a server surely is, but is a notebook? I'm talking one from a well-known brand as Apple, Lenovo, HP, Asus, Dell, etc. So I did a burn-in for a new notebook recently. It went fine and didn't crash the OS even once. The notebook is of a model that doesn't get that very hot. But after some weeks the hardware seems to give up. Recently the SSD has started to act up. So, can a 7 days full 100% CPU load burn-in stress test damage a modern notebook? How would you do a burn-in of a notebook? I guess one could put a fan next to it, but then the temperature would not get that high, and huge part of the reason for burn-in would disappear. Thank you all for answers. But reading them, I really wonder where computing is today. Many say that this 7 days 100% CPU load will be damaging/wear out early to the computer. From my computing background, 1990, this sounds really strange, though I'm not saying it is wrong. What if you have some encoding work to do? Or some 3D rendering work? Those can easily run for 3 days, 100% CPU load. Shouldn't notebooks be used for those things? I can accept that some people are skeptical about my worries about toxic fumes. You want to see proof. Okay. But really, if one can't use a new notebook at 100% CPU for some days, I really would like to see some disclaimers from computer manufacturers, or some kind of admissions from them, that this is the case. This notebook is not suitable for 3D rendering. LOL. I did the 22nd of October 2014, I took a look at the SSD using some diagnostic software. It had information on the temperatures. Highest temperature recorded ever was around 42 and NBSP, degrees Celsius. Highest temperature recommended was circa 70 and NBSP, degrees Celsius. Shutdown temperature was circa 75 and NBSP, degrees Celsius. Conclusion: my 7 days 100% CPU burn-in did not create a high temperature in the SSD, and it kept very good margin to the given max. Remember that I had the notebook in a room that never had an air temperature over, say, 26 and NBSP, degrees Celsius.
Can damage? Yes. Should damage? Usually not. It will reduce the lifetime though, and I do not see any benefit of doing such an extreme burn-in for workstations or even laptops. You'd get nearly all of the benefits by running the same tests for 10 to 30 minutes instead of 150 hours. When you use a device, there's wear and tear. Lifetime of components is not infinite. Many components die after a few years of normal use, some even after a few months, even though they should last forever. There are some things to consider in your case. Some notebooks are quite simply not designed to run continuously at maximum load for 150 hours straight. For most laptops, the cooling cannot keep up with running the system at max load. So when the temperature increases, the system reduces max speed to protect itself from overheating. That means the system will run at full speed, get hot, throttle, get cooler, release the throttle, get hot, throttle, get cooler, etc. The frequency and the severity of these temperature changes depend on the laptop. This will shorten the lifetime of components. Anything with moving parts, such as hard disks, will degrade by being used. SSDs, despite having no moving parts, have limited lifetime based on how many writes are made on the disk. Engineering always involves compromises. When designing a PC, one goal is to keep costs for production down while also keeping costs for warranty repairs/replacements down. This involves designing for the most likely usage scenarios. Unlike laptops, servers can be expected to run under load 24/7, which is why they are designed to last longer than consumer desktops and laptops. That increases their cost. Just compare prices of server hard disks to those of consumer hard disks.
There are several products which will do a better and more efficient job of stress testing new hardware than simply running the CPU. Overclockers use these tools to test out how much they can overclock various pieces of hardware before the system becomes unstable. They do not run the software for a week. A few minutes will usually reveal a problem. Maybe an hour if you want to really be sure. Passmark burnin test. Prime 95. Nova Bench. 3D Mark. Peak Mark. I looked up some information on the brominated flame retardants the OP mentions, particularly polybrominated diphenyl ethers, PUDs, and there is concern about their bioaccumulation. The CDC has a nice facts sheet about them. Note that the section entitled "What are the routes of exposure and the health effects of PUD and PBB?" does not mention vapors from electronics. It does state that PUDs may enter the environment through emissions from manufacturing processes, volatilization from various products that contain PUDs, recycling waste and leach from waste disposal sites, citing Oster 2004. Oster's fact sheet on PUDs and how might I be exposed to PUDs states these ways you might be exposed to PUDs. The concentrations of PUDs in human blood, breast milk, and body fat indicate that most people are exposed to low levels of PUDs. You may be exposed to PUDs from eating foods or breathing air contaminated with PUDs. Workers involved in the manufacture of PUDs or products that contain PUDs may be exposed to higher levels than usual. Occupational exposure can also occur in people who work in enclosed spaces where PUD-containing products are repaired or recycled. In short, unless you're working directly with PUDs and waste, you're not going to be exposed any more than you already are. Be sure not to confuse PBBS, which have been shown to be probably cancerous and have been banned since the 70s, with PUDs which are still being studied and have only been partially banned. As for burning off these problems, I would need a citation on that from a reputable study that A, it's even a problem to begin with, and B, that running a laptop hot does anything to solve the problem. As you can see in the CDC fact sheet, the boiling point for all PUDs is over 300 C. Your CPU is not going to get much over 80 C. Update at Forminator found an actual study about the chemicals coming out of computers and printers. Before you freak out about all the pretty graphs and scary chemical names, note that this is one study on a few computers and printers, which is a sample size too small to draw general conclusions. The study's conclusions about having computers and printers in a small, 20 cubic meters, room is probably okay, but might accumulate, and we need more data. The relevant points are: in almost all cases the computer and printer emissions give rise to concentrations well below guideline levels. Formaldehyde emissions from computers and dibutylphthalate emissions from printers are possible exceptions. Emissions are estimated to come close to or exceed the guideline limits. Also note that printers are way worse than computers, laser printers worst of all. And the report does conclude that aging of computers led to a reduction in chemical emissions. While it doesn't say anything about running at 100% CPU, running it for a couple days in a well-ventilated place before putting it into cramped quarters might help.
The 7-day burn-in should not damage your laptop, and if it does, it was defective in the first place. My laptop has been computing all sorts of distributed computing projects under BOINC for well over 7 years without any issues, and the CPU temperature has been between 70 to 80 degrees Celsius the whole time. In fact, I think there could even be some benefits. Repeated heating and cooling decreases the lifespan of various electronic components and can exacerbate issues with cold solder joints, if there are any. The thermal paste on the CPU could degrade slower when the temperature is high, but stable. Having the CPU fan running at the same speed all the time might also be better for it than cycling it from 10% to 100% as the load changes. I understand that this is all just anecdotal evidence, but my experience seems to suggest that there is some truth to it. Edit: to address the question of SSD life, you probably don't need to worry too much. Modern SSDs can survive a huge amount of writes. The 7 days of testing are tiny compared to what the disk can handle. The folks at the Tech Report decided to do an experiment and abuse several SSDs until they die. Some even survived over a whopping petabyte of written data. This URL.
In response to your edited question, notebook design is the result of compromises between a great many factors: size, weight, battery life, performance, cooling, etc. The average user will not hit 100% CPU usage on a non-gaming laptop for more than a second or two at a time, so a common trade-off is to reduce cooling capability in exchange for a thinner computer. No, your laptop is not meant to be run at 100% CPU for hours on end. Because of other protective measures such as thermal throttling of the CPU, this should not result in the computer failing within the warranty period. A warning about not maxing out the CPU likely would reduce sales and won't provide any benefits to the manufacturer, so they won't have one. As an example, I run system monitoring software on my desktop that logs CPU usage. The largest non-gaming CPU spike in the past week lasted less than 5 seconds.
If you want to support the channel, please consider subscribing.